Hello, my name is Frank. In this video we're going to verify the operations of verify and compare, I should say, the operations of a onboard digital analog converter, a SPI-based chip digital analog converter, and pulse width modulation, which is set up here. The purpose of this is to figure out which one we want to use in a future project. So first up we have pulse width modulation. The way this setup works is it takes the analog input from this potentiometer and converts it to one of our three methodologies. So let's start with pulse width modulation. Here we have our motor. Okay, here we go. Start turning the potentiometer and the motor starts spinning. Keep turning it and it spins even faster. And then that's max, and that's what we want. That is exactly what we want. The only problem that has been noticed with pulse width modulation is if I have an LED here, you can probably see it. There. You could see the LED flickering, even though it's supposed to be at 0. Supposed to be nothing. So that might have to be addressed if pulse width modulation is chosen, perhaps just cutting off values that are below a certain threshold. So let's move on to the on-chip DAC. Okay, now we're set up for the digital analog converter. Right away we're going to see a problem that this has that pulse width modulation didn't. We start turning the pot and there's nothing. Not even vibrating the motor. You have to get to a certain threshold and it kicks on. So that's not exactly desirable. Again, here, show you, focus that. There we go. So we have the pot at 0 here. I'm going to start turning about a quarter of the way. And there we go. So it's only at about halfway that it overcomes presumably some threshold voltage. I go down, and then it could go all the way up. So unless this behavior becomes desirable for whatever reason, onboard DAC is probably out in comparison to pulse width modulation. Finally, we have the LTC1661 chip doing the digital analog conversion. This one, it interfaces with the chip using the SPI protocol, and then it drives the motor in the same fashion the other two did. Unfortunately, the problem with this DAC is even more pronounced than the on-chip DAC. See here. You have to go even a little bit further before it gets to the threshold, and then you could keep going up, get it faster and faster. Alright, so in conclusion, it appears pulse width modulation will win the day, unless, as I mentioned, the behavior of the DAC becomes desirable. Even if it is, for sure, the SPI-based DAC here, it just won't be worth it. Just like in comparison, behaves worse, and it takes up more breadboard real estate and pin real estate on the on our Nucleo board here. Yeah, that's about it. Thank you for watching.